Assalamualaikum and good day to Dr. Abang Muhammad Nizam and Abang Kamarudin. We are from Group 17 to present about the report of our design plan layout, process involved and the changes that was done to improve the existing productions of the product, which is the bike chain. My name is Wanaman Harif with metric number 73873. We'll present about the project proposal description, which contains identification of the key production process, the implementation plan, the proposed plan layout and the adapted flowchart processes. First, for the key production process, we identified the flow process of manufacturing the bike chain. Briefly, the raw materials will be transferred to a machining station. After that, it would undergo the heat treatment process, which is hardening or tempering, depending on the components. Then, it would undergo finishing processes and passes through quality control station. All the wastes and rejected components from these stations will be transferred to a wastage station. From finishing, it would go into packaging, then inventory logistics, and lastly to be dispatched. This is the flow process of how the bike chain was manufactured. For the improvement of the productions, first is to redesign the layout by rearranging the equipment and workstations throughout the factory. Second is to implement conveyors in between the stations and forklifts at the storage. These two improvements can boost the efficiency in transferring the components, thus can greatly reduce the time taken for transporting the product to each station. The third improvement is to recycle the waste or rejected part, which ultimately could reduce the costs of the raw materials. Next is the proposed plan layout. As you can see, the stations are next to each other. Depending on the flow of the process, you can pause the video to study or observe. And lastly is the adapted flowchart or process of the bike chain, which we improved by adding conveyors, forklifts, and recycled the rejected part.
So for the manufacturing process, in the machining process, we start off by pressing or stamping. Pressing or stamping is a method of metal forming where you press a flat metal sheet and convert it into a wanted or specific shape. We first design the shape in CAD and we apply force or pressure on the flat metal sheet to stamp down the wanted shape that we want. In our manufacturing process, the inner and outer plates are the same dimensions and the same material, so we decided to combine the two components into one machine at the same time. Now moving on to the cutting process. The cutting process is where the raw material or the workpiece is inserted into the machine where a tool shapes it to a specific shape that we want by shaving or drilling the workpiece. In this process, we use the rolling method, which is where the tool is turned where the raw material or the workpiece is being held into place. We chose this method because our pin that we will be processing or manufacturing starts from a long wire. If we wanted to install each and every wire every time we wanted to process our pin, that would consume a lot of time. Therefore, we chose to feed the wire into the machine as the machine cuts the wire. Moving on to the chamfering process. Now the chamfering process is a process where we cut a 45-degree angle at the edge of our components. Why do we do this? Well, since our final product requires assembly, then chamfering is essential to ensure that our final product will be standardized and consistent. Chamfering process eases the assembly process and also avoids unattended cuts since sharp edges are eliminated. One more method that eliminates sharp edges and avoids unintended cuts and also eases the assembly is curling. We also use curling on certain components of the final product to ensure that also the final product will be standardized and also consistent, same as the chamfering process. The next part of our machining process is forging. Now, forging is striking a metal piece using a hammer multiple times to shape or deform the metal piece or workpiece to our desired shape. It is usually done in high heats to ease the forging process. And also, the specialty about forging process is it increases the strength of the final product of the forging process. Therefore, important components of the chain requires us to use the forging process because some of these components require high strength and durability to avoid failure or break. Now, to the hardening process. There are two types of hardening process that we will use in our chain, which are case hardening and through hardening. Now, as you can hear from the names, case hardening is just outer layer of the metal piece, whereas the through hardening is hardening the whole metal piece throughout the volume of the metal. Now, both of these undergo the same procedures, which is by heating the metal element and then quickly or rapidly dunk it into an oil, water, or brine, where it cools off and increases the strength, durability, and also tensile strength of the metal. This is also to ensure that the components of our chain will not fail or will not be broken after multiple hits or multiple forces applied to the chain. The only difference between the two is true hardening requires more heat energy because it requires the metal to be fully heated, whereas case hardening is only the outer layer. Now, the last step of our hardening process is tempering. Since case hardening and through hardening only increases the tensile strength and also the durability of the metal or workpiece, it is not that ductile, which means it can break without deforming first. Therefore, we opt for using tempering process to ensure that the metal or the workpiece will not break suddenly and will be safe to use, as we can indicate that the component has deformed a bit and we can replace it in the future. Tempering process is where we heat up the component to a specific temperature that ensures that the ductility that we wanted is achieved, and also the strength and the durability of the component also remains the same. Now, our finishing process. The first one is shot peening. Shot peening is where small round particles made out of metal, glass, and ceramics are randomly hit throughout the whole workpiece or component. Now, this causes plastic deformation only on the outer layer of the workpiece. This also causes compressive stresses throughout the outer layer, which increases the strength of the component and also the resistance to fatigue. Now, grinding process. Grinding process is where we cut or remove a thin layer of metal from the workpiece to ensure that the final workpiece is homogeneous, smooth, and also high quality in terms of finish. This process also removes small impurities and flaws in the final product. And lastly, before assembly, we do tumbling also. Tumbling is 3 discrete steps, which is grinding, smoothing, and polishing. This tumbling process is done to ensure that small impurities or flaws, like really minute impurities or flaws, are removed by using high grit sandpaper during the polishing process, which increases the quality and also standardizes and increases the consistency of our final product. Now, moving on to waste management. Since most of our machining process, finishing, and also our hardening process will produce unwanted waste, we opted for the company to reuse the waste to increase the physical efficiency, which will in return increase the economical efficiency of the company. All the scrap metal are melted back to molten metal and is inserted into a mold that molds it back to a flat sheet or wire. Now, that flat sheet or wire can be reused and be returned back to the machining process where it all starts again. And this ensures that wastage is reduced and the production is increased by the same amount of input that we ordered.
So I would like to explain the manufacturing system, specifically in production machines. So during the productions of roller chain, we actually have a few main process. For example, we have machining process, heat treatment process, and the finishing process. So the things that I would like to highlight in this presentation is the type of automation we use for each process. For example, for the machining and heat treatment process, we use a fully automated machine where actually we can save more time, and the productivity of the machines are better compared to the manually operated machine. We also need an accurate result, so this is the reason why we use a fully automated machine. But for the finishing part, specifically for surface grinding process, we use a manually operated machine. The reason why we use manually operated machines is because it is a cheaper machine where we can have a cost saving that can be transferred to the customer. So then we can sell our roller chain a bit cheaper compared with another company.
For my part, I'm going to talk about the human resources part and material transport system of our group's manufacturing system process. As we know, the manufacturing process of roller chain needs the presence of human workers for operation in the plant as well as the transport system. In this case, our human resources are optimized to drive a forklift truck during the unloading of raw materials and loading of our finished product, which is the roller chain. As for the manufacturing process of the roller chain, the workers are needed for surface grinding as the machine is a manually operated machine. Moving on to the material transport system, 4 design considerations were taken into account before selecting what is best for our proposal. These 4 considerations are material characteristics, flow rate, routing and scheduling, plant layout, and unit load principle. For our plant layout, our group has chosen process layout. We use 2 categories of material transport equipment, which are industrial trucks and conveyors. A lot of conveyors are used in our proposed plant as it will be transporting the raw materials to the machining stations and then to the heat treatment station, followed by the finishing stations, and then into quality control stations. The rejected components at each station are also transported via conveyors into a waste station where the materials at waste station are reused by implementing a casting process. The casting process allows the rejected parts to turn back into raw materials. Finally, the accepted products that has undergone thorough quality control will be sent into packaging as well as inventory and logistics through conveyors as well. When transporting the materials, unit load containers were used so that the transport time can be reduced. This will increase the production rate of our roller chain.
Next is a storage and identification system. We divided it into 4 parts. The first one is the raw storage material. This is the place where we keep our raw material, for example, the coils and wire. We use the bulk storage as the warehouse setting since we want to achieve the greatest density and the higher unit of loads. The second one is the productions of workstation. Basically, this is the place where the individual operations are be done. The third one is the inventory and logistic. So this is the place where the conventional stacker crane are combined with the shuttle technology. This is also the same reason with the first factor. We want to increase the density of the storage. And the fourth one is the identification system. There is one system that we build here, which is AIDC, which stands for Automatic Identifications and Data Capture. It will automatically detect the product and label it from the specification of the product on the packaging. For the conclusion, I would like to say that our group have achieved the main goal of this assignment, where we have improved the plan layout of producing a roller chain. Basically, our group decided to use the wastage from each of the manufacturing process For example, the wastage from the machining process, the heat treatment process, and the finishing process. We reuse the wastage and convert it into the raw material, so then we can cut the cost of the raw material, and at the same time we can increase the productions of the roller chain. I think that's all from us. Thank you.